Chapter 7, Lesson 1, Radicals and Radical Functions. Now, remember that radicals mean roots, like square roots, cube roots, fourth roots. And so we're going to start with square roots. And what I would suggest is making a sheet of, or printing off, square roots, cube roots, fourths, fifths, and sixths, just for convenience to be able to quickly look at your page and find a root instead of trying to work through with your calculator. The first thing we're going to talk about is square roots. So remember that square roots can only happen for positive numbers, because in order to get a perfect square, you have to multiply a number times itself. So if I did 6 times 6, that would be positive 36. And if I did negative 6 times negative 6, that would also be a positive 36. So the square roots can only come from a positive number. So on this first one, we have the square root of 4 over 49. So we ask ourselves, first of all, we have plus or minus because we have the positive and the negative. The square root of 4 is 2, and the square root of 49 is 7. So our two answers would be positive 2 sevenths and negative 2 sevenths. The next one is the square root of 0.25. So remember, there is a positive and a negative answer, and it is 0.5. The next one is the square root of 81, positive and negative 9. And the last one says the square root of negative 81. And remember that right now we can only do square roots of positive numbers. There is a non-real answer, which we're going to get into later in this chapter. So for right now, we'll just write no real solution. Okay, so remembering that from Algebra 1, if we take the square root of a number, it's the same thing as putting that number to the 1/2 power. So if I type in the square root of 49 in my calculator, it'll give me 7. And if I do 49 to the 1/2, it will also give me 7. So therefore, if I take the square root of x to the 8th power, that's the same thing as putting x to the 8th to the 1/2. And when I distribute it, it brings it down to x to the 4th power. So what we're saying is if we are doing the square root of a variable, it is going to cut that variable in half. So this first one says the square root of x to the 12th. So I take 12 times 1/2, and that gives me x to the 6th. The next one is the square root of, plus or minus. The next one is the square root of x to the 6th. So that would be plus or minus x to the 3rd. So now combining our examples from the last slide and this side, the square root of 9 is plus or minus 3, and half of 10 is x to the 5th. Next, we're going to be talking about the cube roots of numbers. So when we do the cube root of a number, unlike the square root, there's only going to be one answer, and you are able to take this cube root of a negative number. So if I did 2 times 2 times 2, that would give me 8. But if I do negative 2 times negative 2 times negative 2, that is a negative 8. So we can take the cube root of negative numbers. So the first one is the cube root of 1, which is 1. And again, there's only one answer. The next one is the cube root of negative 64, which is negative 4. And the last one is the cube root of 8 over 125. So that would be 2 and 5. So 2/5. So since the square root takes half of the exponent, the cube root is going to take 1/3 of the exponent. So in this case, I have x to the 6th, and I'm going to take 1/3 of that. So it'd be x to the 2nd. The next one, I have the cube root first of negative 27, which is negative 3. And then I take 1/3 of 9, which is x to the 3rd. Okay, then we go on to this slide. We have fourths, fifths, square, and a third. So one thing we talked about is square roots, how they have two solutions. Any even root has 2 answers. And any odd root has 1 answer. We also, for any even roots, can only root a positive. And for any odds, we can root both negatives and positives. So for this one, the fourth root of 81 is plus or minus 3. The next one, the fifth root. So if I don't know how to do the fifth root on my calculator, I could do negative 243 to the 1/5 power. Or if it just takes me longer to find the root key, I can just always do it to the exponent. So that would be negative 3. This one is only wants the negative square root of 25, so it only wants negative 5. And the next one is the third root of 64, which is 4. And then it's 1/3 of x to the third would be x to the first. Okay, the next part of this lesson is evaluating values in a function. So we're going to use substitution to find the value of a function at a certain point. So for this first one, it wants me to find the value of 8 in the f function, which is this one. So it wants me to do the square root of 8 minus 4, which is the square root of 4, which is plus or minus 2. The next one wants me to find the value of 6 in the f function. So the square root of 6 minus 4, or the square root of 2, which is a decimal, and we don't want decimals today. We want to leave it in simplest radical. So we're just going to write it down as plus or minus square root of 2. The next one wants me to do negative 1 in the g function. So I'm going to do the cube root of negative 1 plus 2, which is the cube root of 1, which is 1. And the next one wants me to do the cube root of 1 plus 2, which is the cube root of 3, which is not a perfect cube. And so we're just going to leave it in simplest radical as the cube root of 3. The last part of this is going to be graphing root functions. Now we have to understand the basic graphs of roots. So for even roots, it's going to follow our square root function, which is half a parabola starting at 0, 0, pointed to the quadrant 1 side of our graph. And for any odd roots, it's going to be a variation of our cube root, which is an S shape. If I can do it here. There we go. And the higher root you go, so like when you go to the fourth root, the sixth root, the eighth root, just going to be more vertically stretched our root is going to be, and odds are going to be the same thing. So whenever we identify the domain, which is our x terms, notice it kind of follows with our notes we had on the last slide, where even roots we can only take of positive numbers. So for our domain for any of our even roots, are going to be x greater than or equal to 0. And our odds, we can take any integer roots, and so it's going to be all x's. Then we're going to put in several roots that we know, several numbers that we know into our roots, and evaluate our function, plot them, and connect them with a line. So we're going to go down to these ones. This first one, I noticed that it's the square root of x, and so I know that my domain is x is greater than or equal to 0. I want to pick only x's that I can take the square root of, so I'm going to use 0, 1, and 4. So the first one, I'm going to substitute 0 in here. So I have the square root of 0, which is 0, minus 2, which is negative 2. The square root of 1 is 1, minus 2 is negative 1. And the square root of 4 is 2, minus 2 is 0. So I know it's going to look a variation somewhatly of this one here. So I have 0, negative 2, 1, negative 1, and 4, 0. The next one is a cube. So I know that my domain is all x's. And I'm going to pick numbers that I can add 1 to and then take the cube root of. So I'm going to start with -1 because I know that -1 plus 1 is 0 and the cube root of 0 is 0. Then I'm going to use 0 because 0 plus 1 is 1 and the cube root of 1 is 1. And then I'm going to use the next cube root I know is 8. So to get to 8, I'm going to use 7 because 7 plus 1 is 8 and the cube root of 8 is 2. I probably could have picked another negative. Probably would have been better, but we'll just do this. -1, 0, 0, 1, and 7, 2. And I know that it's supposed to be this S shape because it's an odd root. And that is that.